Hi friends, here in this video I would be explaining the concept of angle of contact, or we can say it is also called as the angle of embrace for both the pulleys. That is, first I would be explaining it for an open belt drive, then for a cross belt drive. Angle of contact is called as the angle up to which the belt is in contact with the pulley. From the first diagram, it is clear that the angle of contact is from this point C, E up to A. That is, the belt is not in contact over 360 degree for a pulley. So I would be giving the formula for angle of contact here. Now in case of open belt drive, we can see that this vertical line would be having an angle of 180 degree, or we can say it would be 180 degree or pi radians. Now this is the bigger pulley for the open belt drive, and here the angle of contact is more than 180. As we can see, this angle is alpha and here also there is alpha, so this would be 180 degree plus 2 alpha angle of contact for the bigger pulley of open belt drive. Consequently, when I see this cross belt drive, here I can clearly see that the angle of contact is from this point B, F and up to D. Here this vertical line, this indicates 180 degree, and from both the sides alpha has been subtracted. So for the smaller pulley, the angle theta, it would be 180 degree minus 2 alpha. That is for the smaller pulley. So I'll write it side by side. That is, for the bigger pulley I'll write it over here, for the smaller pulley onto the right hand side I'll say that angle of contact, also denoted as theta. The other name is also called as angle of embrace. Now when I'm writing for the bigger pulley for an open belt drive, the angle of contact is denoted as theta, and this will be 180 degree plus 2 alpha. Now this unit would be in the form of degree. Now when I want this in the form of radian, I can just put the value of alpha or in terms of degree, and finally we can convert it into the form of radians. Now this alpha value is, I can see that there is a triangle when we project this point O2 perpendicular over this radius O1A, and this line O2G is parallel to A dash B dash, and we are getting a triangle here which is in O2G O1. Here there is angle alpha, and this opposite side which is O1 up to G, this will be, in case of this diagram I can see that R1 is the radius of this bigger pulley, R2 is the radius of the smaller pulley. So this smaller radius R2 has been projected parallelly up to the bigger pulley. So here we have R2, the bigger radius is R1, so R1 minus R2 is this side O1G, that is R1 minus R2. So I'll be using the formula of sine here, so that will be sine alpha is equal to O1G, which is R1 minus R2. It is opposite side, opposite to alpha, divided by the hypotenuse, and hypotenuse is this opposite to this 90 degree, which is O1 O2, denoted as C here. So denoted as C. We can even denote it with X, that is the center distance between both the pulleys. Now from this I can say alpha value will be sine inverse of R1 minus R2 divided by C. Now this alpha value would be in terms of degree, and when I get the value of alpha in terms of degree, I'll put it over here, so getting theta in terms of degree, and finally we can convert it into radian by multiplying it with pi and dividing it by 180. So here is the angle of contact for the bigger pulley of open belt drive. Now for the smaller pulley, theta would be equal to 180 degree. Now it is minus 2 alpha. because the angle of contact is less than 180, as we can see here. And over here the value of alpha will remain same. It will be sine inverse R1 minus R2 divided by C. So these are the angle of contact for both the larger pulley and the smaller pulley in case of open belt drive. We can see that in case of open belt drive, when it is larger pulley, here we have plus 2 alpha. When it is smaller pulley, we have minus 2 alpha. Alpha formula remains same. Now I would be going on to the cross belt drive, and as we can see from the diagram of the cross belt drive, for the bigger pulley the angle of contact is from C E A, that is this complete angle is theta, and even here I can say that theta is more than 180 because this vertical line indicates 180 degree, so it would be 180 plus 2 alpha, same as the bigger pulley for the open belt drive. So it doesn't matter if it is cross belt drive or open belt drive, if it is bigger pulley the angle of lap would remain same, that is the formula remains same. So here I'll write it down. For the bigger pulley of cross belt drive, theta is 180 degree plus 2 alpha, and alpha value over here it would be, here this angle is alpha, R1 is the radius of the bigger pulley, R2 is the radius of the smaller pulley, and this same radius R2 has been projected over here. So when I see this bigger triangle, that is O2G O1, opposite to alpha, this is alpha, opposite to it the side is R1 plus R2, so sine alpha would be opposite side, that is R1 plus R2 divided by the hypotenuse which is opposite to this 90 degree, and that hypotenuse is O1 O2 denoted as C. So therefore alpha value will be sine inverse R1 plus R2 divided by C. So this would give me the angle of lap or angle of embrace for the bigger pulley of cross belt drive. The answer would be in terms of degree. When putting into this value of theta, we are going to get it in terms of degree, then multiplying it by pi, dividing it by 180 would give the answer of theta in the form of radians, which would be required in the problem. Next, similarly I'll go for finding the angle of contact for the smaller pulley. Now this part is interesting, that for the smaller pulley of cross belt drive the angle of contact is more than 180. As we can see here, it starts from point B, F and ends over D. Now this angle of contact is more than the angle of contact we were getting in case of open belt drive. This was less than 180, now this is more than 180, so it would be 180 plus 2 alpha, where alpha value would be same as the bigger pulley, sine inverse of R1 plus R2 divided by C. So in short we can say that when it is an open belt drive and a cross belt drive, the angle of contact formula for larger pulley and smaller pulley of cross belt drive remains same. The only difference we get is in the formula of the smaller pulley for the open belt drive, which is 180 minus 2 alpha, and while solving the problem related to open belt drive, we take the angle of contact for the smaller pulley because the chances of slipping for the smaller pulley is more, as the angle of contact is less compared to that of the larger pulley. And while solving the problems related to cross belt, we can use either of them because they are going to give the same value of the angle of contact.